So to graph the feasible region, treat these as if they were equations and graph them like they were normal lines to start. Okay, we'll come back to the inequality in just a bit. Okay, so to graph this, I could graph it by using the intercepts. I could plug in 0 for y, and I get x is 80. Or I could go in reverse. I could plug in 0 in for x, and I get y is 40. And there is the first line. So here I'll color code these. The second line, I'm treating this as if it's an equation. And by the way, if you would use a solid line like I did if it says or equal to. You would remove that. I mean, if that's gone, you would use dotted lines to draw the graph. All these are going to be solid lines because it has the or equal to part of the equality symbol. Okay, this one, if I plug in 0 in for x, I get y is 80. So here's my y-intercept for my blue line. If I plug in 0 in for y, I get x is 40. So here's my y-intercept. Here's my x-intercept for my blue line. And same thing for this one. If you plug in 0 in for x, you get y is 60. And 0 in for x, you get y, you get x is 60. So there's, sorry, I wanted to make that a different color. 60, 60, draw a line between the two. Okay, and then it says x is greater than or equal to 0, so you could draw that if you want, but here's where x is 0. This is the line of x equals 0, the y-axis. X equals, and that's it. And then y equals 0, that's going to be the x-axis, so I don't think we need to necessarily draw those. Okay, so the feasibility region is a region where all three of these inequalities are true. Okay, you want to take them one inequality at a time and do some shading. Like x plus 2y is less than or equal to 80. Let's graph this one first, which is our black line. Where x plus 2y is less than 80. Look, you can test out a point. 0, 0 is the easiest one to test out. If you plug in 0 in for x and 0 in for y, you get 0 is less than 80. That's a true statement, right? That means this point is on this side of the black line. That means all these points are going to be true on this side of the black line. All these are going to be false because it's only true on one side of the line. So I'm going to draw this area with dots. We're going to find out where this intersects with the other areas, with the other solutions. And look, I'm stopping my dots when I get to the x and the y-axis because it said x is greater than 0 and y is greater than 0. Okay, let's do the blue line next. We'll plug in that test point of 0, 0. Really, you could plug in any point you want. You could plug in, what is this, maybe 10, 20, 10 in for x, 20 in for y. Okay. 0, 0 is just quicker. They're both on this side of the line. So if I plug in 0 in x, 0 in for y, I get 0 is less than 80. That's true. So for my blue line, I'm putting dots everywhere over here on the side of this blue line where x equals 0 is. This side is true. This side over here is false, okay, because that's the other side of the line. You only need to test one point for a line. If it's true, it's everywhere. So there's our blue dots. That dot shouldn't be below the x-axis, though. And then the red line, again, our test point of 0, 0. 0 is less than 60. It's also true. So these are all true almost in the same areas, but they don't quite perfectly overlap one another. These are the red solutions. Red is true everywhere on this side. Okay, so our goal is to find out where all these overlap. That's the feasible region. Where do we have black dots, blue dots, and red dots? And I think there's just one region here. Highlight it in this kind of gold color. This is what we'd want to say is the feasibility region, because that's the only place where all these overlap.